Let's review together the following problem. The function below represents a population of fish in a pond t years after a group of fish were initially placed in the pond. What we want now is to answer the following questions. First of all, what happens at the beginning of this population at time 0? How many fish were in the group initially? Well, these immediately tell us, and I would like to remind you here, that we have a function p of t, right? And the p of t gives us the population of the fish. And we have also the variable t that is in years. So the independent variable, the variable that goes to the horizontal axis, is going to be the one that is not affected by the other. So the years are just time goes on, no matter if we have a population, if we have a pond, if we have any fish. So this is the one that goes to the horizontal axis, t, the years. On the y-axis, on the vertical axis, we are going to have the function p of t, that is the population, meaning how many fish we expect to have in the pond at the different times. Okay, we want to find out, first of all, what is the initial population? So this means t equals to 0. Remember that you don't need to be received this information right here. This equal to 0 is in order to help you. But if it says initially, it means initially versus to the independent variable, to the variable that you have right here, the t years. Okay, and this means t equals 0. So in order to find the population at that time, we want to plug in the number 0 in the pt. And this is the function that we have 2,400 divided by 1 plus 23 times e to the negative 0.2 times t. Now, at the exponent, the t is going to be 0, right? Because we replace the 0 at the position of t. Negative 0.2 times 0, of course, is just 0. So what we have right here is the same fraction. The numerator is not affected in any way, divided by 1 plus 23 times e to the 0. Well, e to the 0, as any number raised to the number 0, is equal to 1. So this means that we replace now the e to the 0 by 1 in our fraction, and we have 2400 divided by 1 plus 23 times 1, that is 23. Well, we can see that at the denominator we have 24, so we have 2400 divided by 24, and the result for this 2400 divided by 24 is going to be just 100. Okay, so what is this? This is the population at the beginning. So we start the pond with 100 fish in it. Okay, and that's the answer for the first problem. Now we want to continue with the following question. What value does the population approach as t goes to infinity? Well, again, now we need to work with the infinity symbol, but we need to better understand what's happening. When we have the infinity, remember that the infinity is just a point, but you can always think of it as a very, very, very large number, right? Because this is what it means. It means that the number that is next to infinity is going to be a huge number that always can be replaced by a bigger one. So let me just put the infinity here at the exponent. You have infinity, and this infinity is multiplied by negative 0.2. Let's focus on the e. So what do we have? We have e to the negative 0.2 times infinity. This is going to be nothing else than just e to the negative infinity, because negative number by any number is going to be a negative number. So right here I have a huge number. Think about it. Infinity is just a huge number, but with a negative sign in front of it, because I have a negative number multiplied by a positive huge number. Okay, using the rule of exponents, that tells me that x to the negative k is nothing else than 1 over x to the k. I can bring the e to the denominator, and I have now 1 over e to the infinity. Well, think about this. What is 1 over e to the infinity? Well, what is e to the infinity? E, when a number, any number, and this is the 2.71 number, it's the decimal number 2.71. If you raise this number to a huge number, the number that you have at the bottom, at the denominator, is going to be another huge number. So can I replace it with an infinity symbol? Yes, I can. Okay, and what do I have? I have 1 over infinity. What does this mean? This means that take number 1 and split it into infinite number of pieces. Take a pizza and split it into billion of people. How big is the piece that you get? Extremely, extremely small. How small? Very close to number 0. So basically, e to the negative 0.2 times infinity is almost 0. Can you replace the number 0 in your fraction? Yes, you can. So this is nothing else than 2400 divided by 1 plus 23 times 0 now. And this is nothing else than 2400 divided by, well, 23 times 0 is nothing else than 0. So this is going to be just 1 here. So the result for that will be 2400, 2400 fish. And this is the answer. So basically what you want to do in order to solve these problems is isolate the infinity, isolate the power of e to the infinity, and try to see what is this equal to. Once you understand and you calculate what is this approaches to, because it's not going to be equal to, it's going to approach the number 0. It will never be exactly 0. The whole point here is to find what is the corresponding number that you want to enter in your fraction. So slowly go step by step in order to see how can you make the exponent simpler. So negative number times infinity will give you negative infinity. How can you get rid of the negative sign? By just bringing the exponent to the denominator. What is e to the infinity? Well, it's nothing else, it's just infinity itself. And then see, 1 over infinity approaches 0. And this is a rule. This is something that we always know. You replace now the number 0 into, instead of e, right here, this piece, and you make it 0. And you calculate from that point the numbers that you have. This is how you get your final answer for this problem.